All right, good evening. Can you guys hear me?
Yes, we can.
All right, perfect. Good evening, everyone.
Good evening.
All right, it's good to have you all here. I'm just going to start writing down your names. Salvador and Susanna.
Yes, hi.
Good evening. And William, good evening.
Good evening, Mr. Ray.
And Latavia.
Good evening, Mr. Ray.
Good evening, Jacob. And Marisol, good evening.
Good evening, Mr. Ray.
All right, so I have someone trying to come in under a different name, so just want to write them.
Get out of my right.
All right, and good evening, Justine. Not sure if you can hear me yet, but good evening, Justine.
Hi, I'm sorry I'm late.
No, that's fine. I was waiting till we had a decent number before starting. Okay, and just trying to see who this person is trying to join. All right, so they are not responding. So let me ask you guys, any questions on that assignment that was given? The class, because you're in the same spot as the other class, they had a good bit of questions regarding how to use a table. I remember we had started that. We didn't quite finish it, but we were on unit 3, lesson 5. Any questions about the homework assignment that you would have to do for that?
What page is it, Mr. Ray?
In the workbook, it would have been page, trying to find it now.
74.
Thank you, 74.
To 77.
Thank you very much. That's correct, 74 to 77. All right, so any questions with any of those questions that are on there? Remember, the student book doesn't go that deep. It's really good just to introduce the topic. If you don't have questions, I might just pick some because there are some that the other class chose that they had a lot of issues with, and I could see why, because they're kind of misplaced. So this is your opportunity to ask any questions about that if you did the homework and you had the chance to try it.
I got both on number 9.
Number 9. Okay, let me ask this question real fast. Did you guys receive a message from me while you were waiting?
No.
Out in the waiting room?
Yes.
So you can see. Okay, because there's a person trying to get in, and I have never seen this person before. They don't have a name, and nowadays you have to be really careful who you let into Zoom. So I was trying to tell them they have to change their name to the real name, and then they ended up signing off. So maybe it wasn't a nice person. So anyway, number 9 is the one that was asked. That's on page 75. All right, page 75 is where we are starting. And this is number 9. And I am trying to do something real quick. If it seems like I'm distracted, it's because I am.
What? The way. You can do all things. No.
All right, so number 9, what we have here, it says, the function f of x equals to 50 minus x squared was used to create the following function table. Which number is missing from the table? All right, so let's go ahead and tackle that one. Any ideas on how to do that? We have the function f of x is equal to 50 subtract x squared. And then here's our table. Somebody asked a question. I didn't quite get that.
I'm trying to figure out what book and page are we in?
The workbook on page 75, number 9.
75. Awesome. Thank you.
You're welcome.
Sorry, hi.
Good day, George.
Yeah, I'm just back from work.
Okay, you just got here on time, so we're about to start number 9, page 75 in the workbook. All right, so what we have here is they have f of x, I put y, but like I said, they are interchangeable. So we have -2 is paired with 46, -1 is paired with 49, 0 is paired with 50, 1 is paired with nothing at all, and 2 is paired with the number 46. Now remember, depending on the type of function, you can either predict what it will be, or you might have to just substitute. This is going to be a little bit difficult trying to predict what the numbers will be. You see this one goes up by 3, and then this one by 1. There's not a clear pattern there. And so you end up at 46 again. So you might be able to figure out something, you might not. So let's go ahead and work it out properly. Remember how the tables work. These are what we call ordered pairs. If you're wondering what I'm saying, ordered as in alphabetical order, and then pairs as in a couple, 2. You could think of it as a loving spouse, as a loving pair of spouses, right? So if a spouse is loving to their other spouse, they will always be together. They'll be in the same household. Where one goes, the other will go. And so that's how the ordered pairs work. If you substitute one in, you can find the other. So for instance, if you look at the first one that I circled, -2, x is -2 and y is 46. If you substitute that in, -2, so if you put f of -2 and you said 50 subtract -2 squared in parentheses, you're going to get 50 minus +4, and 50 minus +4 is 46. Exactly what you see there, which means you can find any missing value for y or f of x simply by substituting its corresponding x value. So what is the x value that we have there that we need to find the missing variable?
1.
1. So we want to substitute 1 into that equation and then solve. And what is 1 squared?
1.
1. And what's 50 subtract 1?
49.
49. And there's your answer, 49. And that is literally what happens with quadratic functions. You see a symmetry happening. There's something in the middle, typically. And then on either side, you see it works its way down, kind of like a mirror. So you could have guessed it if you know what quadratics are. And now that you have a basic gist, you could kind of figure it out by looking for that middle. And then everything is symmetric from there on out. We do this later on. We may not even get to quadratics as a chapter because there's not that many questions that are specifically on quadratics. So we may or may not get to it. We really try to cover the basics, enough that you will pass and beyond. So you could get like an 80, 90%. All right, any other questions from?
Sorry, I didn't get it clear. How do we have the F1 and 50? That's why my point is.
The F, say that again?
We have F1, parentheses F1.
We're substituting 1 in there. This is number 9. If you look at number 9, it shows you that the x value is 1. So we're substituting the value of x for 1. And so we're just working that out. We're evaluating the answer. So we substitute 1 in there, right? Wherever we see x, we put 1. and then we just work it out. So 1 squared is 1, and 50 subtract 1 is 49.
Okay, okay. 1, okay. X is 1.
Right.
Okay, okay.
Okay, so any other questions from this homework section? So I'm guessing everyone is comfortable with all the questions that are in here.
So can we do number 3?
Okay, number 3. Okay, number 3, I'm just going to switch pages there. Number 3 has a similar concept here. You have a table, but this one's different. They're asking you to find the equation of the line that will satisfy that table. And this is where we were doing those sequences really comes in, or patterns. So we have X here and Y is on the bottom. Then we have -2, 0, 2, 4, 6. All right, I'm just gonna, this person has been trying to get in, so let me see if it's really one of the people from our class. We've had issues in the past, other teachers, people of, what they call them, trolls coming in and doing craziness. So whoever this is either doesn't see my chat messages or doesn't know how to change their name. And I'm having a feeling it could be a new person. So I'm just gonna tell them, email me and see if they want to get in. All right. All right, so what we have here so far, it's -8 inside there, is -2, 4, 10, and then a blank spot. And then from there, they're asking you to choose which equation is the equation that satisfies this. Now remember, how did we do that last time? On Tuesday, we were learning how to create the rule or the equation of the sequence or pattern. Who remembers how we do that?
So we try and find a relation from X to Y and
Just the Y.
just the Y.
Yeah, if you're talking
Okay.
about the pattern, we're
So-
looking at just the Y's.
Okay, so by what is the relation or the sequence? How much up is it going by, or how low is it going by? Right.
Right?
Okay. So I see so far that it is +6.
Okay, so we're going up by +6.
Yes.
So this answer is number 4. So for number 4, what would be the answer here? The number 4 axis, what would be the next number?
Oh yeah, 16.
So 16. So if you wanted to do number 4, your answer there would have been 16.
Okay.
And just letting it normal. All right, so once you do that, remember what we did. What did we do next? Let's see if anyone remembers. We would say y equals 2. Remember, if it's going up by 6, this represents the multiples of 6.
Yes.
So how do we write the multiples of 6?
Oh my goodness. Okay.
Y equals 6 times 6 to get that 16.
Say that one more time. Y equals 2.
6 Is that
All right, so if you look back in your notes, you should see that once we found the pattern, we would say these are multiples of 6, and the way that we write a multiple is that number times the variable. And in this case, the variable is x.
Okay.
So we write 6x. But there's a little issue here, and that issue is we're not going up by ones in the x values. We're skipping something. And if we're skipping, we're not getting the true picture of what's happening. I'll give you an example. Let's say we was doing the even numbers, 2, 4, 6, 8, 10, 12, 14, etc., right? Notice here, these are going up by 4, but that is not the multiples of 4 that we're really seeing there, since I'm skipping numbers. There are numbers that actually belong in between here that aren't written, but it doesn't mean that it changes what these are. These are the even numbers. And so because we're going up by 2s, I would have to divide that 4 by 2 to really get the picture that we're going up in multiples of 2. So the same thing has to be done here. So if you were having trouble, you're like, man, I have 6x here, but I don't see it. The problem is that these values are spaced out because the other values aren't here. So the number 1 is not there. Number 3 is not there. Do you guys see that? Number 5 isn't there. And so we have to compensate for that. So if those numbers were there, then we wouldn't be going up by 6. What would we be going up by?
By 1.
Well, okay, we have to be careful not to mix up the x's with the y's. Remember, the x's are like the
3?
3, that's correct. It will be 3.
Okay. Wow.
And the way that we find that, literally, because sometimes it'll be hard to see that, is just to look at how your x's are spaced out. Since your x's are spaced out by 2s, you want to divide your pattern
Divide by
2.
2.
Right. Okay, so I'll say that again. When we do this one, it's a little bit different because of those numbers being spaced out. And because those numbers are spaced out, we have to be careful when we write our rule or equation. So although it's going up by 6 and we see multiples of 6, this is not true because we're skipping numbers in the x value. Remember, and you have to study, especially in this level. If you're not reviewing what we did on Tuesday or the day before, you will be lost. So come next week, because we're in algebra, we're going up higher. If you don't review what we're doing now, you're going to be lost next week as well. So you really want to make sure that you are practicing everything we learn. So we have 6 divided by 2. That really gives us what's happening. Is really going up by 3s, but we can't see the numbers that are in between those even numbers. Okay, so if we do that, we get, what is 6 divided by 2? 3x. So can you already see what the answer should be before we even finish? Would it be A, B, C, or D?
A.
Okay, so you could already see that's A, that's correct. But if you want to know how we could finish it off, you could really use any value here to see that, but with the 0, it just makes it easier. If you were to substitute 0 into 3x, you're going to get 0. And the only way you could get minus 2 is if you say subtract 2. And there you have it. That's your equation. Y equals to 3x subtract 2. And you can see that it works because if I was to substitute this in here, y equals to 6 times 3, sorry, the other way around. Y equals to 3 times 6, subtract 2. 3 times 6 is 18, and 18 subtract 2 is 16. So we get y equals to 16.
So the last portion of what this equation down here represents, y equals 3x minus 2, because we used 0 as our point of reference.
Yes, you could have used any of them, but yes,
Find the relation is what is the difference?
Right, we wanted to see, well, if I substitute one of these in and I don't get it, what is that shift? And so you see here that would be -2, because if I substitute 0 in there, I get 0, and the only way I could get -2, and we know that's true because the book is telling us, then I have to have -2. If I had used, I could have used any of them, it's just that 0 was easier. If I use this one and I substitute 2 in there, 2 times 3 is 6. So the question is, well, how would I get to 4? I would have to subtract 2.
Okay, cool.
right? I could have did this with 4, 10. 3 times 4 is 12, but they're telling me I should have a 10 there. So the only way I could get there would be to subtract 2.
Or 12 minus 2, 10.
Right.
Okay.
Okay, so thank you. All right, just letting this person, I think it's Dorcas, so let me just check. Dorcas, is that you? Dorcas, is that you? Galaxy A51? Okay. Hello, is this you, Dorcas? Galaxy A51?
Yeah, that's me. I've been problem logging in.
No, it wasn't. I was sending you messages to see if who it was, because I've never had a Galaxy A51 try to get in here.
Yeah, I'm so sorry because my computer couldn't. I don't know what's going on.
Okay,
with it.
it's only because I don't know if any of you guys have heard, we've had a lot of issues with different teachers all around the world. People come in naked and all sorts of craziness. People come in cursing. So I only let you in, and it's the school policy as well. So the school policy is to only let people in and see your names. So because I didn't see a name, I was trying to send you messages in the chat to say change your name.
Yeah, let me see if I can change the name.
Yeah, so if
I don't know.
it's just what we have to do. I already had an incident with another class where somebody came in and was doing this crazy stuff, and I had to kick them out. So sometimes, I don't know how people even do it, but somehow people hack into the system and they're able to join classes. And I had never had it happen, but we were told to do that. So now I really check on it after it happened to me. All right, so just keep that in mind. If you don't come in under your name, I cannot let you in until you come in under the name that's written in or saved in the computer system. All right, so any questions? Any questions about what we just done? There's a similar one to this, number 26. So if you turn the page to page 77, number 26, it's one that's very similar to what we done here. A little bit more challenging because it has decimal numbers and the X values are larger. But it's the same concept where you have to look at the numbers that are in the table and then come up with the equation that will satisfy the relationship that's happening. So go ahead and look at 26 and see if you can figure it out. Use this, I'll leave this up here. You can use this to try to assist you. Go ahead and try number 26. Think about what we did first. The first thing we did was we looked for the pattern. Then we examined how the X values were going up. And then the last thing we did was try to figure out how the transition worked. So that would be like your 1, 2, 3. So go ahead, this is page 77 in the workbook, number 26.
Mr. Ray, what number?
Number 26, page 77 in the workbook. All right, I see an answer from a person. I see a C has come in.
Mm.
Right, I am not getting a lot of responses. Technically, I'm only getting one. So if you think you may have it, if you do not, how many of you are not sure what to do? Just be honest.
I'm trying to figure out.
Okay, just want to make sure. I didn't want to be sitting here and no one's trying it.
Yeah,
I thought I had it figured out, but I.
Okay, I see some more answers popping in.
This is like the DMV. They all like the right answer.
I know the bottom one.
I like that one.
It's like it's the way you're reading it. At first I thought it was, you know, one then the other. Now I don't know. I could guess all. I'm gonna guess all four of them.
Well, let me show you something that you could do with the
I see the pattern on both, on top and bottom.
So I'm going to take the one that we did in number 3, and this is the long way. I showed you the short way. With the other class, I did the long way first, and then I showed them the short way. With you guys, I just said, you know what, I'm just going to show you the shorter way. The long way would be to just check each one. And for number 3, it just so happens that the answer is the first choice. So what you would do, you check A first, and you would want to see, does it satisfy? So this is the longer way, and it's long depending on where you start, because if you started at D, then you'd be there longer. But in this case, because A is the correct answer, if you started at A, you would be correct. But that's not always the case, right? So you try y equals to 3x minus 2, and you start substituting in and see, is it true? For it to be true, we call it the identity. So if you get anything like 5 equals 5 or 3 equals 3, any scenario where they equal each other, it means that the statement is true. So that's all you need. If it doesn't work out, it means it's false and it doesn't work. So if you try A and you take any of them, right, and you want to do at least 2, like one on one side and one on the other. Because sometimes, as you've seen, some patterns are very similar. So one may work, but the others may not. So try at least 2 of them. And on the other extremes will really help you to see whether or not it's correct. And if you really, really want to be safe, then you could try more than 2. But we have our y is -8, and the x is -2. And if these 2 equal, we know that A is correct. So we have -8. 3 times -2 is -6, minus 2, -8. 8, so that's correct. And that's one way you could have done it. Then you could have tried 6 and 16.
What number are you guys doing?
This is number 1 right now, but they are doing number 26. You could have said 3 times 6 minus 2, and 16. 3 times 6 is 18 minus 2. And because that's true, you would say, okay, my answer is A. Right? Just to show you how it will work with the other ones. Let's say you was trying to
say that again. I don't get you.
Say that again.
Yeah, I don't understand how you do the equation. The other way around, you are showing us.
You mean what I just did here on the screen?
Yeah, -8, then -2. I don't know how you. to prove that the answer is correct.
-8 minus 2. I don't. Where do you have? Where do I have -8 minus? You mean right here?
Yeah, round down there that you are doing.
We're substituting. We're substituting the values of x and y into the equation to see if it comes out to be true.
Okay, it means that a is equal to 2 to the power of minus 2 parentheses. Then I don't know how do you have it. Okay.
You mean right here, this one?
Yeah.
We substituted the -2 right here into x, and we substituted the y right here into this y, and that's how we get this first line right here. So we substituted. We replaced the x's and the y's with their equivalents. So instead of writing x, I write -2. Instead of writing y, I write -8. And remember, this goes right back to the very beginning when we started algebra. When we substitute in there, when we have a number written next to a variable, that is multiplication. So we multiply 3 and -2. 3 times -2 is -6. And -6 subtract 2 is -8. And that means it's true. -8 is equal to -8. So this equation has to be the correct equation. But just to be on the safe side, I also did these numbers right here, 6 and 16. I went on the other side of the extreme because if that happens, they have to be right. And I did the same thing. I substituted 6, and I substituted 6 in for x, and I substituted 16 in for y. And then I'm working it out, and if both sides are the exact same, that means that that is the correct equation. But this is the longer way. I don't do this when I work it out. I do it the way that I showed you guys the first time around. So we have 3 times 6 is 18. 18 subtract 2 is 16. That's exactly what we have on the left side. So that means A is our choice. Does that make sense?
Yeah.
All right, and so you can see that's long because you would have to do that for each one. And so that's why at the beginning, I was trying to show you guys how you can use the sequence that's there to help you to find it very fast. Because if your answer choice was D and you started at A, you would have to do A, B, C, and then finally get to D. And that could take a lot of time. Just to show you, if you had tried B, B says y equals to 1/4 times x. X is negative. If you choose the first one, x is -2 and y is -8. 1/4 times -2 is going to give you -8, and 1/4 of -2 is going to be a half, a -half. And these two are not equal. And because they are not equal, B cannot be your answer. Does that make sense? And that's what you have to do for each one. You have to see where it fails. That's the longer way. But the shorter way, and I'll do the shorter way again, the shorter way can be really short. The more you practice, the more you study, the easier it gets, just like driving, just like walking and using crutches. Everything gets better with practice. So if you remember the rules, we look at the y values for the pattern. So the pattern here was +6. And so we know that we should have y equals to 6x, but we have to take note that my x's are not going up by 1s, they're going up by 2s. So I'm gonna have to divide that by 2. When we do that, we get y equals to 3x, and that is enough to answer the question because it's the only one with 3x. But if I really wanted to make sure what the equation was, I can substitute any x value from this selection and substitute it in there. And if I don't get the answer, I just add what I need. So if I substitute 0 in for x, 3 times 0 is 0. And the only way I could get -2 would be to subtract 2. And therefore, that will be my equation. Now, it would be even faster if I wasn't explaining, but like I said, the more you practice, the better you get at it. All right, so we're going to go ahead and do it. I have a few more answers have popped in. William did it earlier. And William, as I said, you were correct. And Latavia, since going over this stuff, I see you have sent in the correct answer as well as Jacob. So you guys are correct there. All right, so let's go over number 8, excuse me. Number 8, not number 8, sorry, number 26. Number 26 has the table, D for distance. Remember the top row, if it's written horizontally, the top row is, and that's correct, Justine. The top row is like similar to X, is whatever comes first, and the top is normally first. And so if it's horizontally, whatever comes first is like the x-axis. When it's, when it's vertically, whatever comes first is the x-axis. So you have x, y, when it's vertical. And then when it's horizontal, you have x, y, like that. Right? That's the traditional way to do it because x comes first in the ordered pair, because in order, x comes before y, which comes before z, right? So it's all about common sense. Nothing in math is just done haphazardly. Everything is done with a purpose. So we have D there and P. D for distance, P for pressure. Now the distance traveled is going up by tens, not by ones. So automatically it should ring an alarm bell that this is not going up the regular way. We regularly count by ones, but this is going by tens, which means we're going to have to compensate for that once we model our equation. So here we have 14.7, 29.4, 44.1, and 55.8. Right? We don't have this one. That's
No, sir. Mr. Ray is 58.5, 58.8.
Oh, thank you. 58.8.
Yeah.
All right, so 58.8. So first things first, we need to see if there's a pattern here. Is there a pattern?
Yes.
What is that pattern?
It's increasing by 14.7.
Increasing by 14.7. Remember, we are looking at the y equivalents, not the x ones. The y's, the y's, the y's, the y's, and the y's are on the bottom or they come last. So keep that in mind. We're not looking at the top row. I can't stress that enough. If you don't practice that or review it, guess what? Next week, you're going to think the X level. It's just human nature. So you have to practice or else you're going to forget it. All right, so we get plus 14.7, as Gennaro said. I think it was Gennaro going
Yes.
right on up. Okay, so 14.7. But you look down there and there's a bunch of 14.7s. So that means you're going to have to look a little bit closer. So we know at least that we should have maybe y equals to 14.7x. But what is the big problem here? Our x, well, I have here x. I'm going to keep it as x for now and then replace.
Well, I was going to say our X numbers are going by tens.
They're going up by 10. So what did we do?
There you
before? We were going up by 2s.
I'm sorry, you broke up.
What did we do? What did we do before when we were going up by 2s?
We divided by 2.
We divided by 2, but this time we're going up by what?
10.
10. So what should I do?
Divided by 10.
Divided by 10, right? That compensates for me jumping, right? I'm jumping over there. I'm skipping over a whole bunch of numbers. And to compensate for that, I need to do that in the equation. Does that make sense?
Yes.
Yes.
All right, so I got that first part. Now I just need to figure out, am I adding or subtracting any other number? And you could possibly just look down and see that you have a selection. It's either B or D. It can't be A and it can't be C, right? Because, and hopefully, let me rearrange it for you. If I rearrange this and hopefully with all our fractions that we've done, you can see that. If I took this D over 10 and put that D over 10 in the front, and I put the 14.7 on the side, and you see it looks like what's in the book.
Yeah.
So your answer is either B or D, and we need to figure out, do we have to add something to that? So what did we do next in the example in 3? What did we do after that? To test to see if there was something added or subtracted.
We replaced, or we replaced the value and start doing the math to see how far we are from getting the position that we want.
Right, and you could choose any of the variables, but it's always easier to, if you have a 0 up there, to choose the 0, right? If I chose D to be 0 and I substituted 0 in here, what is 0 divided by 10?
10.
0.
0. What is, once you get 0 there, what's 0 times 14.7?
14.7.
No.
0.
0. 0 times any number is 0.
Yes.
You're thinking 0 plus. When you add,
That's why I started with 10.
So 0 there creates a 0. So what could get me to 14.7 if this became 0?
Plus
Add-
14.
I would have to add 14.7 to that. And that's, when you look down, which selection is that?
B.
B. Now that could
Okay.
literally be done very quickly.
Mr. Ray,
It only seems long because I'm trying to explain it. But if you practice that, you can literally have that done in like 30 seconds or less. It's the same thing every single time. If you're given a table and you're asked to find the equation, it's the same thing every time. Find the pattern, see how your x values are going, however they're going, divide by that number, and then just substitute to see what you would need to, move that sequence. And bam, you're done. 3 steps. Did
Mr.
somebody
Ray,
call me?
yeah, I call. Let us try the other way around. Let me see it. Let us say we take 20 for the pattern. Let us see. Let us work it out.
What you mean, like to see if you get it?
Yeah, because of the pattern, let us use for D. We
Yeah,
use
it would be just like we did earlier. Whatever number you use, it still comes out the same. It's just more work.
I just okay, meaning that we have to be 20 divided by 44.1.
No, you divide the 20 by 10. So you have 20 over 10 times 14.7. And you want to see what happens when you get that. You're going to end up with 2 times 4.7. And what's 47 plus 47? Was that 94?
14.
96.
Is
I
it
think that's
14?
96.
14.7.
Hold on, I'm a 9.6. So 9.6, I think it is. You could check me on that. It's evening time. 9.4. So we get a 9.4. So the question is, how would I get from 9.4? Oh, sorry, this is 14.7. Forgive me. I wrote it out wrong. Sorry. Just got to be careful how you rewrite stuff. So 2 times 14.7 is going to give us 29.4. All right, so if I have 29.4 for this one, how do I get to 44.1? Well, if you look carefully, 29.4 is already there for you, which means you would have to add 14.7. And that's how you would get the 14.7. But you see, it's way more work. So the thing is, it's easier just to choose the simple one. And you're working on time. A lot of our students, I think one of the reasons why they don't do well is, along with other reasons, and not saying that not all of our students do well. When students don't do well, and they're like, man, what happened? Sometimes when we find out, it's because the students didn't finish the test. So it's nice if you can do a hard one, but remember, you're being timed. So you always want to just focus on the fastest way to do it, because you want to make sure you can do every single question on the test. That way you increase your chances of getting a good score. All right, but either way, like you can see, you can still get that 14.7 that is needed to finish that equation. All right, does everyone understand that?
Yeah.
Yes.
Yes.
All right, so remember, always choose the easy route. And the easy route is to choose small numbers. So 0, if there is no 0 up there, then choose the 1. But try not to go up higher. It'll just save you time. Now, they don't ask for this, but what would be the next number in the sequence that would satisfy 40?
That's
73.5?
Yeah, 73.5, yes.
Yeah.
All right, so that's how you would do that. Now, any other questions with what's in the book? Now remember, in the student book, you don't get all this. So if you're not practicing the workbook, you're not seeing all the possibilities that could pop up.
Okay.
Any other questions from the workbook?
No, so basically, so it's 3 steps you said, right? First is the your x's,
Right.
whatever number that is times what it is.
Well, you times that by the variable. So
By the variable.
whatever's happening there is your multiple, and you're multiplying it by the x equivalent, which is whatever's on the top.
So I'm gonna divide my x number with the variable, the pattern. Correct?
I don't want to say yes there, but you are dividing the x variable by the pattern of the x variable, if that makes sense. Because the x values are going up.
Yes, in this case, it's the 14.7. Divide that. That's my x number with the 10. Let's go. Since it's going by tens.
Yeah, but you don't want to say 14.7 is your x number.
Okay.
We're not at this level yet, but 14.7, you could call it like a multiple.
Okay.
Or you could just say the x variable. Divide that by the distance between the x's. So if you were going by ones, dividing by 1 doesn't do anything to it.
Okay.
So that's one way you could say it. You could say find the pattern, and then multiply the pattern by x, the x equivalent, because it might be something else, whatever's on the top. The x equivalent divided by the distance between the x's. So the distance between this x is 10.
Okay.
Right, so if you look back here, oh, I erased it? Okay, yeah, so if you look back here, we found the x variable, and we divided it by the distance between the x's, which were 2.
Okay, x times 2.
X divided by.
Oh, x divided by 2.
And then we multiply the pattern by that. And the pattern is the pattern of the y variables.
So that x I look at as a 1?
No, say that again?
That x I'll look at, count that as like as a 1?
No, you count it as x. I'm not sure.
Okay.
Not sure if I'm answering your question the way you
I joined the class after you had right when you guys finished this one, so.
Oh, okay, so we treat x as an unknown variable.
Okay.
So we just keep it as x because we technically don't know what it is yet until we substitute something in there. So it's just saying 6 times whatever x is. So let's say to all of you, I'm gonna, and this would be great if it could happen, but let's say for all of you, I was like, we're going to triple your salary. Well, all of you make different salaries. So I could just represent that by saying 3 times x. And whatever your salary is, you put that in there.
Okay, yeah, makes sense.
That's what x is. So x is just an unknown. We don't know what it is yet until we have it there as a placeholder. So soon when we find out, so if I went down the list, all right, Gennaro, how much do you make? And then I'm like, okay, 3 times that, bam. Then I ask Jacob, how much do you make? And then George, and I go down the list. And so I just substitute that variable in. That's literally what the x's are. It's just saying, as soon as I find it out, I substitute in there and work out for my answer. Does that make sense?
Yeah.
Now, remember the tables, these are just positions. So it's just showing you the 0 at the 0 position, it's -2. At the 2nd position, it will be 4. At the 4th position, it's going to be 10, right? And that position could mean many different things. It could mean years. It could mean the position in a race, right? It's just basically, it's what everything is dependent upon. All right, so let's try another one.
Okay.
There's a few in here that, you know, the other class they were saying was causing them a lot of trouble. And I'm just going to go over those ones. Okay, so the other ones we're going to go over are not similar to what we just did. They're very similar to number 9. You notice that they have powers and whatnot, and they look a little bit different. So the first one would be number 21 on the same page. And this one says, an archer shot an arrow at an angle of 45 degrees. The distance and height of the arrow along its path were recorded at several points. The data is shown in the table below. So we have this table here. The table is very similar to other ones we've done. We have distance representing the x variables, and then we have 1, 2, 3, 4, 5 representing the meters to travel. Then on the bottom we have h for height in meters, and after the first meter going across, it was 0.8 meters high. As it traveled 2 meters, the arrow was recorded to be 1.2 meters high. After it traveled 3 meters, the arrow was recorded to be 1.2 meters high. And then as it traveled 4 meters, it was noted to be 0.8. So you see the arrow is coming back down and then nothing, right? We need to figure out what that is. So basically, the arrow was shot like this. We call that a parabola. So there's like a guy standing here. He's got his little arrow. See if I can draw that. Right, he's got an arrow there. And he's gonna shoot that arrow. And the arrow is flying up high. And the arrow reaches a peak, which you see here. And once it reaches the peak, it lands. Or is close to landing, at least. So we're not sure where it is, but we want to try to figure that out. So that's a real life situation, and we can literally do that in real life. And so now for number 21, they are asking, this one's a bit different, so you got to tackle this one different. Which equation expresses the relationship between h and d? Now notice here, there's not a clear pattern happening. This is 0.4, this is 0, and then this is minus 0.4. So it's not a clear pattern. That means that we're not dealing with a regular, what we call a linear equation. We haven't got to that part yet where we name things, but naming them helps. A linear equation is an equation where you have no powers happening. This is not a linear equation because of the x squared. This is also not a linear equation because of the cube. This is an example of a linear equation because there are no powers involved. And so when this happens, when there are no patterns, you can safely assume you are dealing with something that does not look like what you're used to. You are possibly dealing with an exponent in there. It could even be a rational exponent or a fractional exponent. Remember, we dealt with these. It could be something like that. The moment you don't see a regular pattern is the moment you're dealing with something that could look like that. This can help you in choosing your answers. If you look at A, B, C, and D, which ones should it definitely not be based off of what I just said?
C and D?
Definitely not B. So it could be C or D.
Oh.
Right? It should not be A and B because those are what we call linear. They have no powers.
I had it backwards.
Now you got it, right?
Yeah.
So basically, if there's no pattern that's happening between the numbers, then it's not linear. That means that we are not going to be dealing with just a variable. We are going to be dealing with a variable that has a square, or it's a half, or it's a cube, something of that nature, the moment this happens. Does that make sense?
Yes.
All right. So we know it's not A or B. That can narrow down our choice selection. Now, it doesn't make sense for me to try to show you a shorter way because then I have to literally teach you a whole lesson. So this is where that guess and check comes in. We eliminated A and B, so it has to be either C or D, and we can use that substitution method to help us here. Are you guys still with me?
Yes.
Yay.
Yes, sir.
Good.
Yeah.
All right, so let's try C. We're going to use C, and we're going to substitute values from above to see if it will satisfy the equation. And if it does, we know we have the correct equation. Do you guys remember I was talking about that?
Mm-hmm.
Okay, so that's the equation for C, and we're going to test to see if C is correct. So we could choose any of these. I'm just going to start with the first one there. So h is equal to 1 minus, and I want to see, does this equal to 0.8? 1 minus 0.2 times 1 squared. All right, so we have 1 minus 0.2 times 1, because 1 squared is 1. 1 times 0.2 is just 0.2. And what is 1 subtract 0.2? 0.8. Is that true? Did that come out correct?
Yes.
Yes, it did.
Yes,
More
it
than
did.
likely, this is the correct answer. But sometimes you can have answers that work for multiple ones, so we could just try one more. So we can try h is equal to, just going to substitute in, my d is 4, minus 0.2, 4 squared. H is then equal to 4 minus 0.2. 4 squared is 16. H is equal to 4 minus 0.2 times 16. And 0.2 times 16 is the same as, I'm trying to think this in my head. So 16 times 0.2 is going to give us 3.2. And what does 4 subtract 3.2 give us? 0.8. So is that correct? It's correct for both of them. So that means my answer is C.
C.
Did I hear D? My answer there would be C.
Mr. Ray, I'm in
Yes.
doubt because when you were doing it, I was writing. Where do we
Okay, so
have the,
what part did you miss?
yeah, for the initially, H is equals to D minus 0.2D square. But where do we have the 0.2?
The 0.2 is given in the choice selection for C.
Okay, because I was trying to find it by, for instance, considering position D 1 and 2. So considering both of those amounts, and I was trying to go 1.2 minus 0.8.
Oh, yeah.
So it gave me 0.4. So that wasn't it.
No. And they have it there. And if you look at number 22, they have that there because they know some people are going to do that.
Right? Yeah. Okay.
Now, this is what we call a quadratic. Sometimes it is really easy to solve a quadratic because on the other side, it's symmetric. I don't know if you see it. These two are the same, and then these two are the same, which means if there was a 0 here and something, it would be the exact same over this side for 5. So it's a pattern. That's the nice thing about parabolas. Once you find one of their tables, it's really easy, certain times, not every time, but sometimes it's really easy to predict what the next thing will be as well. All right, so the answer there is C. Now we can go ahead and try to find number 22. All right, so I'm gonna do number 22 right in this area. Any questions so far? George, did that answer your question?
Yeah.
Okay, perfect. Any other questions?
Yes, sir.
All right, so number 22, did somebody say something?
Oh, no.
Okay, number 22, we could take that same formula now, and we want to find out what happens when 5 is in there, so we know what h is when it's at 5. So we have h is equal to 5, subtract 0.2, and then we just square the 5. So our h will be equal to 5 minus 0.2 times 25. And 0.2 times 25, I could do that one in my head. That's going to be 5. And what's 5 subtract 5?
0.
0. So number 22, the answer
Is A.
0.
A. 0 meters.
0 meters. So basically, that diagram I drew, he shot the arrow up, and more than likely, he was standing at 0.8 feet when that happened. So the arrow would have possibly been at 0.8 feet, And so when he first shot it, bam, it goes up in the air, the arrow comes down and plop, right down on the ground. And that's what this is happening. It's just showing you the path. So this is what they do, stuff like this at NASA. When you see the forensic people trying to look at an accident, they're doing stuff like this. They're measuring the distance and they're measuring what happened. And then they can predict where it either started or where it could have ended. Because everything follows some form of pattern. And we can model that mathematically. And that's why we can predict a lot of different things, whether it's we can predict when the full moon's going to happen 35 years from now, 6 hours, you know, we could figure it out right to the day, right to the time, right to the second, because everything follows patterns in this world. Very remarkable. And because of that, the math laws that just exist, it's not that we create them, they exist and we're discovering them. And it just shows us how complex the world is. But it also allows us to make this world much easier. Because if we can predict what happens for predictable events, then we can make life more luxurious and more comfortable. All right, so that's how you would do number 21 and 22. Now we're going to look at number 27. And these are the questions that were really causing a lot of trouble to everyone. The reason why is they look completely different than what we were doing in the student book. So, you know, that's why I knew we should have questions. And I'm just going to go over the questions that were asked by the other class. So number 27 was one of them. It's the last question in that page. And we see here a table, T for time, and H is the distance, the vertical distance a ball is dropping. So we have here 0.54. We have 1.0 and 16, 1.5 and 36, 2.0, 64, and 2.5 and 100. All right, so in an experiment, a ball was dropped from a tall building at t equals 0 seconds. All that means is the person's still holding the ball. So that means that the timer hasn't started yet. The person's waiting, and just like you do when you was young, or even still now, you're waiting for the person to click the timer, then you let go, right? So the person clicks the timer, the person lets go, and a half a second later, the ball has dropped 4 feet. I think it's in feet. Yeah, 4 feet. 1 second later, the ball's at 16 feet. 1.5 seconds is at 36 feet. At 2 seconds, 64 feet. At 2.5 seconds, 100 feet. The ball's falling really fast down to the earth. So they have the recordings here. We used to do stuff like this when I was in high school. I have the students go out and measure things, and then we can predict when the ball will drop and all that different stuff, right? The same way how radar works. The radar is bouncing off the signal from the car back, and the calculation's been set inside the radar gun, and bing, a number pops up for the police officer, right? Same thing happening. You can predict stuff. So we have here, the rest of it says, the relationship between distance and time should be h equals to half a times t squared, right? So we have h equals half at squared, where a is a constant determined from the data. What is the value for a? Any ideas of how to do this?
No.
All right, it's good to be honest. Now remember, what I said to you guys last Tuesday gone, is if all else fails, just substitute.
Yeah.
If all else fails, just substitute stuff in there. And remember, treat these things like they're spouses, which means they are connected. They are ordered pairs. Whatever you substitute, the other one should go in there with it. So any ideas what we could do?
Well,
Very similar to what, go ahead.
Start substituting.
Yeah, let's substitute. Substitute what?
Well, we start. We can start with 0.5, that t.
We could.
And then start going through our options, A, B, C, and D.
Okay, we could do that. And I'll just let you know, all you need to do is 1, because what are you looking for in this question?
The value of A.
Value of A. And if you have these values, well, then it's going to allow you to find A. And you do have these values. You do have a whole choice of values that you can put in there to help you find A. Now, remember, you want to choose the easiest route. So what would be the easiest ordered pair to choose?
From 1 and 16.
1 and 16 would be the easiest, right? So 16 is H. We have half. We don't know what A is, but we do know what T is. T is 1. And 1 squared is just 1. So we end up with 16 equals to half times A. Who remembers how to solve for A? The shorter way.
Oh, we do the opposite of it. We try and isolate it.
Right, so we can multiply by the opposite of a half, which is the reciprocal 2/1. That will cancel, and what we do to one side, we do to the other. And 2/1 is just the same as 2. So what's 2 times 16?
32.
32. So what does our A equal?
32.
32. And done. Which choice is that?
B.
B. Now remember, you could have done that with, go ahead.
Why do we choose 16 and 1.1?
You could choose any of them. We chose that one because it's the smallest number. 1 is easier than 0.5. If I asked you to multiply in your head and I gave you a choice to say you can either work with 1s or a 0.5, which one would you choose?
I think one is okay.
You choose 1, right? 1 is easier to work with than 0.5. And that's what you want to do in the test. You want to choose the easiest route. Don't make life hard for yourselves. Always make it easy. And, you know, you might have heard the statement, don't reinvent the wheel. But I do want to show you that it doesn't matter which one that you choose. So let's say you chose the first one, 0.5. That means H would be 4 instead of 16. And then you have a half A times 0.5. And you square that. Now, it would be easier if this is a fraction. So I'm just going to rewrite this as a half. Is everybody okay with that? 0.5 is the same as a fraction as a half. Okay, I'm going to take that as a yes. So if we square a half, this goes back to the laws of exponents that we learned about when we were doing Unit 1. If we square a half, we square the top. So 1 squared is 1. And we square the bottom. 2 squared is 4.
Okay.
All right, and when we multiply fractions, we multiply straight across. So we can ignore the A. We can ignore that for now and just multiply the fractions. It looks like a 9. If we multiply just the fractions, 1 times 1 is 1, and 2 times 4 is 8. And you see why we choose the smaller numbers. So we have 1/8 times A. How do we solve for A?
We do the opposite of it.
We can multiply by the reciprocal, 8/1. What we do to one side, do to the other. Remember, 8/1 is the same as 8. Over here, they cancel. And what is 8 times 4?
32.
32 as well. It doesn't matter which one you choose. You will always get the same answer because they are connected by an unbreakable pattern.
Can you please leave them up a little bit?
Sure. I'll do one more while you're copying. Let's say I wanted to choose, I don't know, somebody say 1.
0. 1.
Going twice, I didn't hear anyone, but I'm going to choose the harder looking one, 2.5 and 100. So if we chose those ones, we would have 100 is our H, half A times T. T in this case is 2.5. I could write this as a mixed number, and that's 5/2. I mean, an improper fraction, sorry. So it makes it easier if you're doing it by hand. If you're using your calculator, you just trust your calculator. But by hand, it's easier to keep it as a fraction, believe it or not. So we have 100 is equal to 1/2 A. Remember, 2.5 is 5 divided by 2. It's half of 5. So 5/2. So if we square 5, that's 25. If we square the 2, that becomes 4. right? And so when we multiply fractions, we multiply straight across. So when we multiply the half and the 25 over 4, 1 times 25 is 25. 2 times 4 is 8. And we have 25 eighths times A. How do we get rid of that 25 over 8?
We do the reciprocal.
Multiply by the reciprocal, 8 over 25. What we do to one side, do to the other, 8 over 25. Now you could do 8 times 100 is 800 divided by 25, right? But that's, I mean, that takes longer. If you remember, I taught you guys the cross canceling. So you could divide 100 by 25, that would be faster. And 100 divided by 25 is 4. So you end up with 8 times 4 is equal to A, because these cancel out. And what is 8 times 4?
32.
I don't know.
I'm having a hard time with these fractions at this last portion of doing the reciprocal. And so we're canceling. I'm just using the very first one as an example.
Right.
16 equals a half times A. The reciprocal is 2 over 1. So we cancel, but you still brought over to one side that 2 over 1 equals 2.
Well, because 2 over 1 is 2. So, I mean, you could write 2 over 1. I wouldn't technically write 2 over 1 at all. I would have just, by myself, I would have just wrote 2. But I really want to make sure you guys know we're multiplying by the reciprocal, and that's why I put the 2 over 1.
Because we are still multiplying by the reciprocal, not necessarily
Right, the reciprocal of 1/2 is 2. But a lot of people just, you know, it's new information. So for a lot of people, they don't see that it's the same thing.
No, I'm still having a hard time trying to.
Right, so
when we
I mean, if it really helps, I could put 2 over 1 right here.
Okay.
And then 2 over 1 times 16.
2 over 1 is 2 times 16.
And 2 times 16 is 32. So, you know, you could just write 2 and...
So now with the last one that you just did, 8 over 25. So what did that give you? What is 8 over 25?
You mean like what does it reduce to?
Is that what you did?
No, I canceled it out on the right side. And what I did to one side, I do to the other. And
so how did you end up with this 8 over here?
Well, can I erase this pink stuff? Because I was really working on a tight area there.
Yeah.
Yeah.
Okay, I didn't hear any no's. So I'm just going to do the green part over, because you do want to know how to do your fractions. You will have to see them again in geometry, as geometry is basically algebra on shapes. And it uses a lot of fractions. All right, so for this one, if you were to substitute 2.5 t and 100 for h, we would have 100. I did this in green. So we would have 100 equals to 1/2 a. My t is 2.5 squared. But 2.5 squared by hand is more difficult to do than in fraction form. So hopefully everyone knows that 2.5 is 1/2 of 5. And 1/2 of 5 can be written as 5 over 2.
Okay.
Now, if you're doing it by calculator, you don't have to worry about changing it to a fraction. It's just it's much easier when you're dealing with computation to work with fractions. Some people may say they don't think so, but it really is. It's really difficult working with decimals and multiplying the decimals and squaring the decimals. It's easier to do it with fractions. So we have 100 is equal to 1/2 a times, we square the numerator and we square the denominator. So 5 squared is 25, and 2 squared is 4. Then we need to multiply the fractions together. You remember, multiplication is associative, meaning it doesn't matter what order I multiply them. So the a is in the middle, but doesn't matter. So we multiply the 1 and the 25, the numerators. 1 times 25 is 25.
25.
We multiply the denominators together. 2 times 4 is 8. So we have 25 over 8 times a.
Okay.
Now this is where we're solving. Now, you guys may remember, I showed you the long way is to do this, but this takes up a lot of space and a lot of time. And I showed you guys that if you do this every single time, you're going to see that every single time, right before you get to the very end of doing that, you're going to see that you're going to have the reciprocal. And logically, it makes sense. The opposite of 25 over 8 is 8 over 25.
Okay.
And they literally cancel. If you were to multiply 25 by 8, you would get the same number as 25 times 8. And so because of that, you end up with the same number on top of each other, and any number divided by itself is 1 and cancels out. So instead of doing all that work every single time, we establish it in the beginning, and then we now use that rule that we found out to say it cancels.
Okay, yes.
But what we do to one side of the equation, we do to the other. So we're multiplying this side also by 8 over 25.
Mm-hmm.
Now, we could do it the long way, but we have done fractions enough, hopefully, to know that there's a shorter way to do this. And the shorter way is to divide diagonally. We call that canceling. So 100 divided by 25
It's 4.
is 4. So those cancel out to 4, and I'm left with just 8 times 4. That's much easier than saying 8 times 100 is 800. Then I have 800 over 25. That's a lot of work. So we can use stuff that we have already established, and this is why I say everything we learn, you want to try your best to try to study it, because we build upon it to make life easier. So we have 8 times 4. That's equal to A. And what is 8 times 4 equal?
32.
32. So we end up with 32 is equal to A, just like we would no matter which one we choose. We will always get the same answer because they are a pattern, and that's how patterns work. And the world is covered with patterns. The human body is literally covered with patterns, right? When we create cars and laptops and software, it's just we cannot escape it. Everything has patterns. Seashells, you name it. So because of that, we can create tables to help us to visualize what's happening. So the tables just show us a connection, whether it's time related to distance or whatever it could be, pressure and distance, you name it. But as long as we know the connection of how to interpret what's happening in the table, we can use that to solve for missing variables or solve for desired variables. All right, hopefully that has helped out a lot.
Thank you.
Any other questions? We've covered, I think, almost all the questions which everyone asked in the other class. Maybe 1 or 2 we left out. Let's finish this with an easy one. I hope it's easy. Let's finish this with number 1 on page 74. So we're going to kind of settle it a bit. Remember, these questions I chose were questions that the other class was like, Mr. Ray, these things were, I didn't know where to start. And when I looked at them, I said, okay, yeah, they were a bit challenging. But remember, it's very possible these type of questions could appear on the test. So you want to practice all the rest of the problems between now and Tuesday. We do have class next week, Tuesday. We just don't have class Wednesday, Thursday, or Friday. So if you have classes on any of those days, it's a holiday, so keep that in mind. Wednesday, Thursday, Friday is a holiday, but classes are still Monday and Tuesday. So if you have a class on Monday or any classes on Tuesday, there are still classes on those days. So just keep that in mind. All right, so I have an answer that was thrown already. D, I haven't had the chance to see if that's correct. Let me just check. Yes, that's correct, Justine. All right, so you're doing number 1, and number 1 says the distance of a train from station A was measured at different times as the train traveled to station B. A record of the train's position and time is shown in the table below. And so then the time is given. We see there the time T. Time T, I haven't wrote a T like that in a long time. Time T is 1, 2, 3. No equations here, so no real hard work. 4, 5. And then the distance in kilometers is given as well. 80 is the first one, 140 is second, 200 is third, 260 is fourth, and all they ask you is for number one, how many kilometers from the station will the train be after 5 hours? What is this missing one here? That shouldn't be too difficult. What is it?
320.
You said
320.
320.
Oh, 320. I thought you said 20. I was like,
320.
320.
That should be
All
D.
right. All right. So
Yeah.
yes, that's correct. It would be 320, and that choice is D. If you're not sure how there is an increase, how much is this increasing by?
60.
60.
60, right? Positive 60 to be exact. And that means all you would need to do is add 60 to 260. I would do number 2 for you, but you can try it in the mix. Number 2, because it goes along with number 1. So because it goes along with number 1, I don't want to leave it blank. How many kilometers from the station was the train when it began its trip? So can anyone figure out what that would be? You don't have to do much math there. Just use the same.
That's 60.
It could be A, 20.
That's 60,
Okay.
Mr.
Say that again.
60.
Okay, I heard 60, and then I heard George, you said 20, I believe.
20.
Okay, Salvador agrees with George with 20.
Yes, 20.
20. All right.
20.
So another
20.
20s, all these 20s. All right, let's see if these 20s are correct. Well, you could do the same thing. If you wanted to work your way down from 320 back to 260, you just subtract 60. And if you wanted to go from 260 back to 200, well, you just subtract 60, and vice versa. So if you wanted to go back to the start, when time was at 0, before it began, then you just need to go back how many?
60.
60. And what's 80 subtract 60?
20.
20. That is correct. You are using 60, but you're using the 60 to subtract from the 80, and that will give you 20. All right, hopefully you guys are starting to see how the patterns and the tables
No, I think that's
all work. Is somebody asking me something?
Yeah, I didn't understand how you got 20.
Because everything's going up by 60. So if you work your way back, you're going down by 60. And the starting time would be 0, basically. Right? So if I was to push this back some, the starting time would be when time was 0, when it hadn't started, when no one pushed the clock yet. Right? We're waiting. You know, like if it's a race, everybody's waiting for the timekeeper. So at that time, it's at 0. So if you wanted to know how many kilometers from the station was the train when it began its trip?
I got it.
Okay, perfect. It would be at 0, and so therefore it just goes 60 back down from 80, and that's 20. So it started at 20 miles away, and then each hour you see it's increasing by 60 miles because 60 kilometers, sorry, because the train is traveling at about 60 kilometers per hour or so. Okay, does that help?
Yes.
Okay, how do you guys feel about that section? Was it challenging?
This one's
Yeah,
cool.
maybe with the table.
This one made a lot of sense.
Okay, so did it help? So do you have a better understanding than before?
Yeah. These last three problems, yes.
Yeah, those were the problems that the other class found the most challenging, those who did the homework. If you did not do the homework, there are still some problems in here that I did not do. I would suggest that you try them, and Tuesday, if you did not understand them, to have them ready. This, like I said, what we're doing in the algebra is literally the foundation for everything. If you can get past this, you can even figure out stuff that we haven't done. Like literally. Remember what I said, these are corresponding values. If all else fails, what did I say to do with those corresponding values? Did anyone get it?
I don't remember.
No, no one remembers.
I think
Good.
Say that again.
We substitute.
Substitute. There we go.
Oh, there you go. There you go. Now I remember.
If all else fails, substitute. If all else fails and you see an equation and you see some points, just go ahead and substitute it in there. For instance, turn to page 85. We might not even get to this. I'll just be honest. I don't think any teacher really gets to it like they want to. But turn to page 85 and look at number 23 on the workbook.
Solve the system.
So you see there it says solve the system. Now I'm pretty sure most of you have not seen this before. You don't have an idea of how to do it. So what could you do being that you don't know how to do it?
I do.
Substitute those values in, right? The -3 represents x. Remember, they are ordered pair. The x goes first, x, y, z, a, b, c, d, x, y, z. So the -3.
Question what?
Number 23.
Okay.
So you would just substitute that in, right? If all else fails, substitute it in and see if it's true. If it's not true, it's not correct. Remember, for it to be true, one side has to equal to the other side. If that happens, that's the correct answer. Does that make sense?
Mr. Let us do it together because.
Yeah, why not? Let's just try that one real quick. I won't be able to teach you right now. I'm not going to do it yet. I'm not going to teach you how to do it, but this is one of those things where you can answer it without knowing how to do it, if you get what I'm saying. So we have 7x plus 2y equals to -11, and 3x plus 5y equals to 16. Now there's the method to solve for this. If it's a fill in the blank, well, you know, you're just going to have to skip it. But if they have a multiple choice, well, that means you could choose one of the correct answers. So if we look at A has -3 and 5, which is your x and your y, right? X goes first, x, y, z. They are an ordered, that means it's in order, pair. They correspond. They are like husband, wife. They're like spouse. They're like white on rice, right? All those phrases that people say. They go through it thick and thin, best friends, whatever you can think of to remember that. If one goes in, the other has to go with it. And if the other's not there, you can find it. That's the relationship, right? And with that, you can solve just about anything that's thrown at you. So if we try this out, we can see if it's true. 7 times -3 plus 2 times 5. If that equals to -11, we're on a roll. If it doesn't, we could just scrap it. We don't have to worry about the second one. 7 times -3 is -21. Plus 2 times 5, that's 10. That actually equals -11. So we want to check the second one. The first one works. Let's try the second one. 3 times -3 plus 5 times 5. If that works, we've got our answer. If it doesn't, we've got to check B. 3 times -3 is -9. 5 times 5 is 25. -9 plus 25 is 16. We got our answer. Bam. You didn't even know how to do that, but you could get the answer. Does that make sense?
Yeah.
Wow.
Yes, sir.
So let me just pick it
And
up.
that could work. I'm glad you asked that, George. Thanks for saying let's do it. That's a prime example how some of the problems that we may not get to, because I'll just be honest, we probably won't get to how to do this. And most teachers don't. We have one semester to try to cover a lot of material. That's how you can get through that question, even though you don't know how to do it. And a lot of questions like that you can do. Let me see if I can find another one where that could work. Oh, another one. Page 87, number 10.
Page
Can I
87.
go here yet? Is anyone?
Page 87.
87, number 10 on the same book.
Okay.
Is anyone still copying this?
Equation.
Is anyone copying this?
No, sir.
Yes?
No.
Okay, no. All right. So page 87, number 10 is another example of something we may or may not get to. It's asking you to solve this equation. Right now, you don't have the tools to do that. But you do know that you can substitute something. Let me just make, yep, it says, which of the following is a possible value of x? Which means one of these things, A, B, C, or D, means that it could be x is equal to -10. It could be x is equal to -8. It could be x equals to 8. It could be x equals to 10. So I don't know how to do this, right? So what could I do? Because I want to try to get every question right, and this happens. What can I do? What's that word we're looking for?
Substitute.
Let's go ahead and substitute. So if you can, go ahead and try it. Right, -10 squared plus 8 times -10. And what must this equal to?
0.
Zero. If I get 0 on the left side, I know that I'm correct. Negative 10 squared is 100 plus negative 80. They like choosing A for these ones. So 100, negative 80 minus 20 is negative 100. And it just so happens, again, that our first one is 0. But do not think that every first one would be the correct answer. But it just so happens that these two, A is the correct answer. But I've done that without knowing how to solve for it. Do you get what I'm saying?
Yeah.
So it could end up being the long way, but if your first selection is the correct answer, then you could just move on. Now, if it doesn't work, you might have to try -8, and then try 8, and then try 10. So, you know, just if it's A, yay. If it's not A, then just keep chuck-a-looking away. All right, so those are examples of how you could just substitute something in if all else fails. Another example, page 91, number 9. Did everyone copy this?
Yes, sir.
All right. If you look at page 91, number 9, you see something like this. And I don't want to be here all day, so can somebody look at the back for this one just to see what the answer is? It'll be funny if it's A again. So they want you to solve that. When it's a multiple choice, if all else fails, what can you do with multiple choice? If all else fails.
Page 91.
Yes.
Substitute, right? Page 91, yeah, number 9. I'm just trying to see what the answer is for this. Just want to save time, so this is lesson 9. If you find it before me, just let us know what that answer is, number 9. Okay, it's going to be C. So just to save us time, they have here, I had a feeling it would be A again. I didn't think that probability was that high. So x equals 2, x equals to 3, for C, x equals to 5, and that's supposed to be the answer. And then D, x is equals to 10. So let's say you get on here, you're like, what is this? Right? And I'm pretty sure most of you are probably saying that, right? Who's saying that? What is this? Anyone?
I don't know. Oh, wow.
Does anyone know how to do it?
No.
All right, be honest. Number 9, this is page, just in case you're not sure, page 91, number 9. So you don't know how to do it. You're sitting there like, man, like, why do you have so much of these crazy problems on there? And then you remember, if all else fails and it's multiple choice, do what?
Substitute.
Substitute. And you start substituting away. Now, this one says C is the correct answer, so we're just, for time's sake, we have 2 over 5 plus 3 plus 2 over 5 minus 3, and that has to equal to 2 squared minus 9. So 2 over 8 plus 2 over, what's 5 minus 3? 2. And then 20, that's 4 minus 9, that's a -5 over 20. And 20 divided by, and tell me if I make any mistakes, 20 divided by -5 is -4. 2 plus 2 is 1, and 2/8, that is 1 over 4. That don't look right. I must have done something wrong. Hold on. 5 plus 3 is 8. Yep, that's right. 5 minus 3 is 2. 2 squared is 4. 4 minus 9 is -5. 20 over -5 is -4. Did I look at the right number?
Mr. Ray, where do you have 5? Because I'm seeing 2 over 3. Or 2, that is the question is 2 divided by x plus 3. So where I believe that x represents 1. Why do we have 5?
Well, because the answer book says 5. I said I went back to the answer book to see what the answer would be. And it says x equals to 5. And it doesn't look like 5 works unless I made a little mistake. Does anyone see me? Did I make a mistake anywhere?
Mr. Ray, how did we get 2 in the bracket and then 2 at the top?
I can help you find a place if you turn on location services.
Sorry.
Say that again?
We're dealing with a 5, right? So when you get over to 20, is supposed to be 20 over 5 square minus 9.
Thank you. I did not see where I made that mistake. Thank you, Latavia. I was like, I know it's supposed to be 5. So I figured it was somewhere I made the mistake. Thank you. That's where the mistake was. It should have been 5 squared minus 9. Thank you, Latavia. Saved us a lot of time because clearly I must have been too tired to pick that up. All right, so 20 over 25 minus 9. And what's 25 minus 9?
That's 16.
16.
16, right? So we need to see if this is true. Now, this is easier than the way that you have to do it if you don't know what you're doing. And your calculator can do a good bit of this, right? Don't forget your calculator. You can put 1/4 plus 1 in your calculator. And remember, I'm running out of space here. So hopefully you've written this down. 1 is the same as 4 over 4. And if we used to add those, we get 5 over 4. And if we reduce this fraction by 4, divide both sides by 4, both numerator and denominator. 20 divided by 4 is 5, and 16 divided by 4 is 4, and that's correct. So if all else fails, substitute. And thank you again, Latavia, because I did not pick up that I put a 2 there.
Yeah, I realize.
Yeah, I was trying to figure out, I was like, I know I messed up somewhere, but.
Yeah, Mr. Ray,
Yes.
My question is, solving, talk of solve 2 over x plus 3.
2 over x plus 3?
Yeah, but we have 5. That's why I have the problem. I've not been seeing, because I was thinking that the x should represent 1.
No. Okay, do you have the book open to page 91?
Yeah, I'm on page 91.
Okay, so
then
if you look on page 91, I try to write out what the possible answers are. Possible answers are x equals 2, x equals 3, x equals 5, x equals 10.
Yeah.
Now, because it's multiple choice, you have the option of just substituting back in to find out what the correct answer is. So if you don't know how to solve it, you can just try to substitute and see which one will be true. Now, x is not 1, nor is it ever 1 by default. X is only 1 if it says x equals to 1. We're going to use the possible answers to see which one is correct. Is that making sense?
Yes, sir.
We're basically working backwards.
Yeah.
Instead of trying to solve it down to see what x is, we're going to see which x is it by just substituting back in and working backwards. We're working our way up. Does that make sense?
Okay.
Right?
Yeah.
So technically, I wanted to start something before tonight was over. But technically, you want to be trying every single one. You'll try x equals 2. That wouldn't work. It will fail. Then you try x equals 3. That's not going to work either. It will fail. And then you try x equals 5. And then hopefully you don't put in 2 instead of 5. And then bam, you get the answer. And you're like, whoo, I got this hard answer just by substituting. Are you guys getting what I'm saying?
Yes.
Yes.
So I'm just going to be straight up. We're not going to get to all of this stuff. But if it's multiple choice, if it's not fill in the blank, if it's fill in the blank, then you're just going to have to skip it and don't try to waste your time on it. And they don't give a lot of hard questions like these. They give mostly what we've been doing before, the functions and tables and graphs. We're going to do the graphs next. I was going to start tonight, but we're going to be doing the graphs on Tuesday as well. But if all else fails and you have multiple choice where you can choose, just take that choice and start substituting in to see which one will make a true statement like you see here on the screen. Is everybody understanding me?
Okay.
Yes, sir.
Yes.
Right? And you could do that for a lot of them. So for instance, we're still on page 91. For some of them, you won't be able to do. Like for number 1, it'll be very hard for you to try to do that one. So you just have to skip that one possibly, or you could guess it, right? Sometimes it's best to just guess. Number 2, though, you have values in there that you can substitute in for y, and you can work out to see which one is correct. Is that making sense?
Yes.
So this is the test strategy that I'll say. If you get to something like this, it looks really hard. There's an option where you can flag it, right? Make sure you read the instructions on how to do that, especially when we do the practice test. You can flag it, and once that thing is flagged, you can come back to it at the end of the test. So when you come back to it, let's say this is literally the question on there, and you're like, man, I don't know where to start on this one, but I have answers here and I don't know what else to do. So I'm gonna substitute and I'm gonna start with A, then B, and then C, and woohoo, I got it. And then you can go on to one like number 2 on this same part of the pages. And you can do the same thing. Are you guys getting what I'm saying?
Yes.
So the ones you know how to do, you go ahead and do them so that you can just hurry up and get it done. Just like we were doing with the tables. I was trying to show you guys the short way is to actually work it out. But the longer way, you can at least get the correct answer. So if you have time, you can go back and do that. Just substitute the values. And guess what? With your calculator, you can make the fractions easier. And hopefully you've been practicing the calculator, like I said, because if you're practicing how to do it, once you get on the test, you're not going to feel anxious trying to figure, oh man, I forget how to change it from scientific notation, right? That's why you want to be practicing. So it's just a quick, easy fix. You don't want to get stuck on there. And that's why you're practicing. Take that test, you pass it, you're done, right? You're done with it. You got your GED and life goes on. All right, we have 12 minutes. And with that 12 minutes, I want to start this new thing. And we may not finish it today, but at least you'll be exposed to it. And this is back to the student book. I see a question though, okay, great. Yeah, those are test strategies that we teach to students typically. Where is it to? All right, so we're going back to the student book and we're looking at we're skipping all that stuff, lesson 7, 8, and 9, and we're going to lesson 10. If we have time, we'll come back to those ones. If not, those are the things, if all else fails, substitute, if you have that option. All right, so now what we're gonna do, we're just gonna start lesson 10, and lesson 10 on the student book is page 68. All right, so we're looking at inequalities, and I'm gonna switch back to a blank screen to do this as fast as I possibly can and see if I could get it done in 11 minutes with you understanding everything that I said. All right, so hopefully you guys remember we touched on inequalities at the very beginning of the class, and we learned about these symbols. Do you guys remember what these symbols mean?
Yeah,
Greater than and less than.
Ah, great. Which one's greater than?
Greater is going on the other.
Greater is the second one.
Second one.
No, it's the first one.
Greater than.
This is greater
Oh,
than.
okay.
The one way that you can remember is we read from left to right, right? We say greater than.
Okay.
We read from left to right. It's the same thing with the symbol. Which side has the bigger side? The left side or the right side?
Right side?
Well, the right side, imagine if you're drawing people there, right? Little person here and big person here.
On the left side.
Right, the bigger side is on the left, and we read from left to right. So we literally say greater than.
Okay.
Right, so how would we say this one from left to right?
Less than.
Less
This
than.
is less than, right? So we read it from left to right. Remember, everything in math is built off of common sense. It's built off of somebody was like, okay, how can we do this? Oh, let's do this, right? That's basically how we can make the notation.
Can you also read that as the mouth eats the bigger number?
Yeah, you could do sharks. You could do whatever you
Okay.
want. You could draw a little Pac-Man there with a face. And the guy eats the bigger number, or the shark eats the bigger one, the crocodile eats the big, whatever it is that makes you remember it. That's what you want to do. So this one here is what again?
Less than.
Less
Less
than.
than.
What is this one called? Does anyone remember?
Greater than, equal to.
There we go. That is greater than or equal to. I'm just going to put equal to. I'm trying to be fast. And this one would obviously be less than or equal to. And it's basically the same thing, right? So I'm just going to put here colon, a line, colon, double line. So it's the same thing there. So greater than, less than, greater than or equal to, less than or equal to. Greater than or equal to literally means greater than or equal to. But instead of having to write that multiple times, the two symbols have been combined to create this, right? Same with this one, it's less than or equal to, but we combine them together to create that. Okay, is that clear? Do you guys remember that?
Yes.
Yes, sir.
All right. Can you guys hear me? Because Justine's saying she can't hear me too well.
You were breaking up.
I can hear you.
Better now.
I can hear you.
Okay, it sounds like it's multiple computers happening because some people say they can and some people can't. But you know, remember, everyone is basically home nowadays, so the internet is normally stressed beyond measure, and so it's going to happen. All right, so just to show you how this works in real life, come on, pen. How it works in real life, for an example, we normally would use variables just to represent all the possible solutions. So, for instance, to drive on the freeway for most states in the US, a person, to drive on the freeway by themselves, a child, a person rather, has to be greater than 18 years old. Actually, greater than or equal to, which means they can be 18. Now, there's a difference, because if you are strictly less than 18, you cannot drive on the freeway by yourself. Does that make sense?
Okay.
Yes, sir.
Now, the greater than or equal to means that you include the 18-year-olds. In this one, if I say strictly less than 18, the 18-year-olds are not included. Does that make sense?
Yes, sir.
Right? The greater than or equal to means if you're 18, assuming you turn 18, you can drive on the freeway by yourself, and if you're older than 18. Whereas this one says, if you're a day before 18, you cannot drive it. I'll give you a prime example. When I was renting a car on my honeymoon, I was trying to rent a car. I was 24. I got married, I guess you could say young. And I was turning 25 the next day. I was literally turning 25 the next day. And I was coming from the cruise. I was trying to rent a car. And it was cheaper if you was 25. It was like $100 cheaper. And I was pleading with the guy. He was like, nope, sorry. We're going to charge you the extra $100. And I was like, I literally turned 25 tomorrow. And he was like, you're not 25. I literally just did not make it. I was one day away. And it was like 3 o'clock in the afternoon. I was like, so you're telling me if it was midnight, you would let me get it for less? And he was like, yep. Prime example, less than means you're not included. I was not included in the ability to get that car rented for less. Does that make sense?
Yeah.
Yes,
Now
sir.
you need to know this because they're going to combine everything that we did with equations and expressions, which means you're going to have to read something and you're going to have to write it out, just like we did with the equations, but put an inequality sign there, which means you have to think about this. Are they including the child? Are they including the 18-year-old, or are they excluding them? Are you guys getting what I'm saying? So it's really important that you understand those symbols, that if I have greater than or equal to, I'm including the person. If it's strictly less than, like what you see here, I'm not including the number where I'm starting at. All right, so that's our example. Now let's just try to do one more thing. Oh, sorry, the sketching. We might not get to do the solving part. We'll pick that up on Tuesday. But once you do that, let me go back to the screen. Once you do that, we can also sketch these things. And the way that we sketch them is as follows. So you see there's some little lines. And if I was to draw a number line, we learned about number lines under integers. And I was to put 0, it's going to be in the middle. And I'm going to skip a few, right? Let's just say we're doing by 3 6s. So he's going by 6, 12, 18, 24, and then -6, -12, -18. The way that I would sketch this would be, we use circles to show where we're starting with the number. So 18 is over here. Now, normally the circles are right on the line, but I want to make sure everybody can see it. And then I'm saying everyone that is older than 18. But not only am I saying everyone older, but I'm also including the 18-year-olds. And to show that on a graph, we fill in the circles to say that the 18-year-old is included. Does that make sense?
Okay.
Yes.
That means let's just say it was 18, and if I had made it after midnight, he would say, you made it. You're 18. You're included. And so if he was to show that, we would fill in the circle. So a filled in circle says the person is included. The last thing is, what do we do when we have less than? And because I don't have time to try to sketch that out, I'll just change the color to red. If we have an 18-year-old, this one here, so we're going to do this one, the one on the bottom. We're going to do this one as well. Let me circle it green. So this represents the less than 18. Less than 18 means that my circle starts at 18 again, but do I fill it in?
No.
No, because it's not included. And I'm saying everything that is less than 18, and so it goes this direction. Does that make sense?
Yeah.
Why do we put the arrow negatively?
Well, I mean, it's just an example. I know I'm using the example of children and stuff, but let's just assume that these children can go into the negative round for now. In a real life scenario, you will stop at 0, but I just want you guys to know that it means less than.
Okay.
Now, you're right. This doesn't make sense. And so if I wanted to make sure it made sense, like what George just asked, and hopefully everyone has this down now. If I wanted to make sure it made sense, I can't have children that are in their negatives, so I would need to have a limit. So how far would I go if I was doing that? Well, I don't want people driving at 110 years old if they could live that long. And so I want to have a limit. And to have that limit, what we can do is say that our x is greater than or equal to, we can write it backwards, than 18. So these are the people that can drive. So if they can drive, they're older than 18. Look, it's written backwards, but it still means the same. The x is on the greater side, and that's why you want to know how to read it. If I was to read this, I'm saying 18 is less than or equal to x. If I read it the opposite direction, x is greater than or equal to 18. And I do that so that I can include the age limit. So let's say the state says once you hit 80, you can't drive anymore. Now what this means, if I was to draw this on a number line, it means everyone that is 18 to everyone that is 80 can drive on the freeway. Does that make sense?
Yeah.
Yeah.
So that's how we can satisfy what George asked, and vice versa. When are we given the ability to drive? At what age?
16 and a half.
Around 16 and a half, so let's just say 16. So if I was to draw it for those who can't drive on the highway, or the freeway rather, so if you can't drive on the freeway, that's the top one, then I could do it this way. It's those who are strictly less than 18, no equal sign there, right? Strictly less than 18, but they are greater than 16. And that's how I can make it more realistic. So glad you asked that, George. That's a perfect example of what that will look like. And so if I was to draw that on a number line, on the number line, that would be 18, this would be 16. It would basically be everyone within this range. So if you're 16, it's greater than or equal to, sorry. If you are 16 or older, you can drive, but you can't drive on the freeway. Does that make sense?
Yeah.
And if it didn't, we are going to review that on Tuesday. If it did, that's great for you. You were able to follow along. All right, so both of these should be on the YouTube channel by tomorrow. I didn't upload Tuesday because I had a lot of stuff going on, but both of these will be on YouTube. And so you can always review these. I will review it on Tuesday. But like I said, you use this more than you know. And I experienced it when I was 24. I did not make the cut. I was not included, and I felt horrible. And I had to pay a lot of money. So remember that, that's where we're picking up. You can start this also in the workbook. You want to optimize your time. So remember, review the stuff that we were doing earlier today. But if you want to do this in the workbook, actually you should do this in the workbook. Page 94 in the workbook to page 97 is where you can start doing it. Have questions for Tuesday. If you do, it will help you to understand. Please try it. Please do your best. Please come with any questions on anything that you find challenging. And we'll finish and pick up there on Tuesday. All right. Hopefully you were able to retain everything. You guys have a great evening.
So again, can you repeat the pages that we can start looking at?
I have to open my book again, but for anyone else who has to go, have a great evening and hopefully see you guys on Tuesday. This is on page 90. Someone has it, you can say it.
94 to 97 on the
Thank you.
workbook.
94 and 97 at the workbook.
In
Thank
the
you.
workbook, page 94 to 97.
Thank you,
Dorcas?
everybody.
Dorcas, you have your hand raised, or was that a mistake?
Good night.
All right, night, Jacob.
Thank you, sir.
Mr. Ray, thank you.
You're
Thank you,
welcome.
Mr. Ray.
Enjoy your evening. Be safe.
you.
Enjoy your weekend.
Yeah, Mr. Ray, I put my hands up. Yeah, because I was having problem logging in today with my computer. I don't know what's gonna happen on Tuesday.
No, it
So-
wasn't you, Dorcas. Remember, I had said your computer had came up as Galaxy something, and I wasn't letting you in. That's what the problem was.
Oh,
It wasn't you. It's just that we have a protocol that we don't let in names that are not on our register. So because you were logging on under Galaxy instead of Dorcas, I wasn't letting you in. But I was sending you messages. I guess you didn't see them. I was sending you messages saying change your name, and then I sent a message saying send me an email if you don't know how to do it.
I was seeing the messages, but I was wondering, I didn't know how to change my name because it's for my cell phone. Because my laptop that I was using, I keep putting in the ID and the passcode. I don't know if it's a network, but it's not going through. So that's why I use my cell phone.
Well, this time, that's what it was. If it was another time it wasn't happening, I don't recall. But this time, that's what was happening. Because it was coming under Galaxy, I under protocol that we have at the school, we don't let anyone in that comes in under any other name or alias. But as long as you do what you did last week, you should get in as long as your name. If you come in, let's say it comes in on some other name, just send me an email saying, I'm trying to get in and I can't.
Okay.
Yeah, so
And
that's
I did
what
that
happened.
too. I don't know if you got my messages too. I also sent emails too to you.
I saw your email. That's why I let you in.
Oh, okay, okay.
Yeah, when I saw the email, I was like, okay, that has to be Dorcas then. And I went and let you in.
Okay.
Yeah.
Okay, thank you, Mr. Ray.
You're welcome. All right, enjoy
Okay,
your
have a
evening.
good.
Okay.
Okay, you too. Bye.
All right, bye.